Okay, example sample problem 5.3. So this is the question. Draw the shear and bending moment diagram for the beam and loading shown. So the question asks you to draw the shear force diagram or also the bending moment diagram. Okay, previously we have learned that in order to draw the SFD and BMD, we cut into several sections. So first we cut in here 8.1, and then we cut at here 8.2, and then 0.3 here, and then 0.4, 0.5 here, and then 0.6, and then 0.7, and then we cut it 0.9. So we did that like this example. Okay, like this example, when we cut into several section 1, 2, 3, 4, 5, 6. So this is the classic way in order to find at each point what is the shear force V and what is the bending moment. Okay, what is the shear force 1, 2, 3, 4, 5, 6, M1, 2, 3, 5, 6. Okay, we calculate. But actually, once we actually know the principle, we actually do not need to calculate at each point. We can apply the relationship between a shear and load to develop the shear diagram. Okay, so first for this problem, okay, so first you can take the entire beam as a free body, determine the direction at A and D. So because for this problem you have a beam like this. From A, it has A like this, and then you have 90 kilonewton, and then you have 54 kilonewton, and then you have at point D, FD, and then you have a uniform distribution load from D to E. From D to E, you have what we call UDL. So in which that if this is acting in the middle, it is equal to 22 times 2.4, which is 22 kilonewton meter, is equal to, in every 1 meter it has 22.4 kilonewton. But because it has 2.4 meter, so 2.4 meter is equal to 22.4 times 20 times 2.4. So 22.4 times 2.4 is equal to 52.8 kilonewton. Okay, so this is actually 52.8 kilonewton. So but we don't know what is FA and we don't know what is FD. So you have to find this. So in this example, we do not need to calculate every shear force and every bending moment at each point. We do not need to do the sectioning. We do not need to do the sectioning. We just apply the relationship between shear load to develop the shear diagram, and also apply the relationship between bending moment and shear to develop the bending moment diagram. So in this example, we are not going to do in a classic way like we did in the previous example. So we just apply the relationship. So I will show you. Okay, so first you have to find what is FA and what is FD. So to find what is FA and what is FD, you have to go as usual, what is summation of all forces in all y direction is equal to 0, and the summation of all moment in all these things is equal to 0. At point, maybe you find at point B, and then you can find what is FA and FD. Okay, so this is the solution. Okay, so maybe we can write somewhere in here. Okay, so to find FA and FD, you can use either this is M. You can use either one. You can start with summation of all forces or summation of all moment. So let's say you start with of summation of all moment, maybe you can take at point A to find the relationship with D. So moment at point A is equal to, so if you consider this direction as positive, so it is equal to minus 90 times 1.8. Okay, minus 90 times 1.8, and then minus 54 times 3.2. No, 4.2. This one is 4.2. And then minus 52.8, which is this one. So this one is actually eating in the middle. So 52.8 times, so this is 1.2. So if it is in the middle, so this is 1.2. So 1.2 plus 3 plus 2.4 plus 1.8, you will get 1.8 plus 2.4 plus 3 plus 1.2, you will get 8.4. So you times with 8.4. So you will get, and then you have a D, also you have D. So FD, because FD is going counterclockwise, so it is plus FD times 3 plus 2.4 plus 1.8 is equal to 7.2, should equal to 0. So you got 7.2 D is equal to, if you calculate here, you get 832.32. So if you divide with 7.2, so you get FD, this is FD, is equal to 115.6 kilo Newton. So when, and then for summation of all forces in y direction is equal to 0. So if you consider this as positive, so it is FA positive minus 90 minus 54 plus FD, which is FD is 115.6, and then minus 52.8. So you will get FA is equal to 81.2 kilonewton. So that is why you got FA is equal to 81.2, and then you get FD is equal to 115.6. Okay, so because you already have this FA 81.2, so this will go up. So when you construct the so when you construct the shear diagram, you start with FA. You start with FA in here, right? Because it is going up. Because you start with here. So the value is 81.2. Okay, so if you, this is 0, this is shear force, this is 0, so this is B, this is C, and this is D, and this is E. So because it is 81.2, so it is, let's say this is 81.2, let's say, let me check. Okay, so this is 81.2, so it starts with here. So because from A to B, there is no any force acting in this section from A to B, so for the shear force it will become a straight line because there is no force from here to here. So in shear force diagram it will become a straight line, and then suddenly at point B you have 90 kilonewton force going downward. So because it goes downward, so you have 81.2 minus 90, so you will get minus 8.8. So this one, because it has 90 kilonewton going downward, so it will fight with this force. So this one is minus 8.8, so this will go down to 8.8. okay, and then because there is no any force acting between point B to point C, okay, so it will be a straight line for the shear diagram. So it will be a straight line, and then at point C you give another 54 kilonewton going downward. So from 8 to 8 minus 8.8, so minus 8.8 minus 54, you get 62.8, minus 62.8. So this one will go down. Let's say this is minus 62.8, so it will go down to minus 62.8. And then because there is no force acting from C to D, from here to here, so this also again will become a straight line for the shear force diagram, until you give 115.6 kilonewton going upward. So this is actually minus 62.8 plus 115.6, so this is equal to 52.8. So this will go up to 52.6. So let's say this is a 52.6, a 52.8. So it will go up to 52.8. So it is here. Okay, so for this, from D to E, as it is a uniform distribution load, it will create a shear diagram either it will create a shear diagram inclined. Either it is like this or inclined like this. But because it is already 52.8 here, and at point E it should be 0. The shear force at point E should be 0. So it will be inclined like this. It cannot be inclined like this. It should be inclined like this. Okay, because at point E it should be 0. So that is why you get the shear diagram like this. Okay, so and now we construct the bending moment diagram. So this is 0. So this is point B, point C, point D, and point E. Okay, so for okay, so for bending moment diagram, we can construct by calculate the area under the graph for each of this section from A, B, B, C, C, D, and D, E, and then this value is actually the value of the bending moment. So let's say from A to B, this is A, this is B, This is C, CD, this is E. So from A to B, the bending moment value is actually equal to, so this is for BMD. Where should I write? Maybe here. Okay, so from A to B, the bending moment is equal to 81.2 times the distance is 1.8 meter. So it is 146.2, and this is positive. Okay, so this is 146.2, and then from B to C, the bending moment is equal to, because this is minus 8.8, so minus 8.8 times the distance is 2.4 from B to C, so it is equal to minus 21.1. So this is equal to minus 21.1 kilonewton meter. This is kilonewton meter. And then from C to D, this is 62.8, so minus 62.8 times the distance from C to D is equal to 3 meter, times 3 is equal to minus 188.4. So this one is for this one, or for this one. This is 1 minus 188.4 kilonewton meter. And this one is from D to E. It is equal to half 1/2 times base. Base is the distance. The distance from D to E is equal to the distance from D to E is 2.4. The distance is 2.4. Base times height. Height is equal to 52.8. So the area, so we calculate area under graph of shear force diagram equal to bending moment diagram. So this one you got 63.3. Okay, so now you have this value. So for bending moment diagram, so for the bending moment diagram, to create the bending moment diagram, if the bending moment diagram, if the shear force diagram shows a straight line like this, the bending moment diagram, the bending moment diagram will be either inclined like this or like this. So for this, because it is, okay, so we calculate here. So for bending moment diagram, because at A to B, it is equal to 146.2. So it will start from 0, definitely from 0 to 146.2. So let's say this is 146.2. So because the shear force diagram is like this, is constant like this, straight line, the bending moment diagram will be either like this or like this. But because it is from 0 and then it goes to 146.2, definitely it will be like this. So it goes here, 146.2. And then from B to C, also the shear force diagram is like this. This is from A to B, this is from B to C, also like this. So the bending moment diagram either like this or like this. But because you see that it is now is minus 21.1, it is definitely like this because it goes down, because it is negative. So from B to C, it is 146.2 minus 21.1, which is equal to 125.1. So from B to C, because it is straight line in the shear force diagram, it will either become inclined like this or like this. But because it is negative here, it is inclining like this. So it goes to 125.1. So let's say this here is 125.1. Because we calculate, we get 125.1. So it will go down like this. Okay. Similarly, from C to D, it's still a constant straight line like this. So from C to D, this constant straight line like this. So the bending moment diagram, it will be either like this or like this. So at point D, because it is minus 188.4, so from C to D, because it is one, so you have to minus from this value 125.1 minus 188.4. So you get the value is 630 minus 63.3. 63.3. So let's say this is minus 63.3. Okay, and then from D to E, because the graph is like this, if the graph is inclined like this or like this, the bending moment diagram will become a quadratic or a parabola graph, either like this or like this or like this or like this, something like that. Okay, but because at point E, bending moment will become 0, so definitely it will be, the graph is like this. Okay, so that is how we construct the shear force diagram and the bending moment diagram without actually do the sectioning at all point like we did in the first and the second example. So you can write in here, this is no. So you can write in here, this is 146.2, this is 125.1, this is 63.3, this is 0.